So this is a reminder for me to start recording, and then we will define a boiler fitting. Pressure equipment safety regulation. Some of you have this. They are small booklets that were recommended that you buy. If you don't have them, no need to run out and buy them. This might be the only question out of the pressure equipment safety regulation that you could possibly come across for the fifth class. Those particular books, if you want to have them or feel a need to have them, they can be printed offline. Printed from an online source and actually printed, and they're legal to be used in your exams. So, and in that regulation in Alberta, you will find that a fitting means a valve, a gauge, a regulating or controlling device, a flange or pipe fitting or other appurtenance. So this is a piece or a part of a system that is attached to or forms part of a boiler, a pressure vessel. This includes fired heaters, pressurized coils, thermal liquid heating systems, or pressure piping system. So really a lot of things. We've looked at boilers and we've looked at parts of boilers, but the things that, all the little bumps and appurtenances are also part of the system, and they come under certain regulations. We'll talk about the regulations, and we'll talk about what these fittings are. So here's a list: pressure gauges, siphons, safety valves, gauge classes. This is a small list. If you were to make a list of examples of a couple of things of each item listed here, you'd have a much larger list. Safety shutoff valves, quick opening valves, stop valves, check valves, and vent valves. So this is a short list. We'll look at quite a few things. Okay, this would have been a hidden slide, so that reminds me to go to this version. All right, let's get my highlighter.
Go back a quick second.
Go back to this one.
Your little hidden list.
It's gone now, sorry. No, there it is. Okay, it's
yeah.
We're going to repeat and repeat and repeat all night. And if you review these PowerPoints outside of class, you'll be able to see all the hidden slides. Each PowerPoint has some. There's just too many. I tried to make it less, but if I make it less, you don't see everything. If I show you all of them, we only have 100 hours, and a bunch of those hours are used up in exams and reviews. So, and you'll do better on your exam if you review the PowerPoints on more times than just going through in class. Okay, so going through in class and playing the recording, that's not going to cut it either. You got to review the PowerPoint on your own. So pressure gauges, we're going to look at pressure gauges, a little bit about their construction and some things that some of you may not agree with, but you have to know what it says in the text. And an example is, the text says pressure gauges are graduated in KPA. Certainly they are, but many of them are not. And we'll talk about that when we get to a siphon. It's sometimes called a SYPHON, that's still pronounced siphon. They're sometimes called siphon pipes or siphon tubes, or pigtail is a name for a siphon. When you see a picture of the standard siphon, you might understand why it's called a pigtail. This is an essential fitting. This is a very important fitting, so you need to understand. One of the things I like to remind people, and when we go for a tour of the lab, I'm going to keep reminding myself that keep reminding you that I'm thinking about that, so I actually remember to bring it together this term. Try to bring it together this term. We'll go to Nate. Sorry for the folks that are not in town, but there is a virtual tour of the lab in your Moodle. If you can't track that down, I may go through it one time. So the fitting between a steam boiler and a pressure gauge. Safety valves, we're going to have a closer look at safety valves. We'll look at safety valves quite a bit on different kinds of equipment. We'll talk about popping action and disc lips. Gauge classes we'll look at and talk about. We'll also look at gauge classes that are mounted on water columns. This is sort of the end of the bigger list there, the things that are in these chapters. What is a gauge class? Something to indicate the level in the drum or the shell. Okay, something to indicate the level, and we'll be looking at them. I think I'll start with I'll try this little video. I think it's quite short. Ground is rumbling here. They are digging another hole in my street, right in front of my house. 41. Welcome and good evening. Glad to have you all back. Let's try this video.
Proper maintenance of water level instruments on a boiler is crucial to keeping your plant running safely and efficiently at all times. We're going to demonstrate how to conduct a proper blowdown procedure on a boiler water gauge glass and a remote level indicator. But first, let's understand the purpose of these vital level indicating instruments. The water gauge glass on a boiler enables the operator to visually observe and verify the actual water level in the boiler. However, if not properly cleaned and maintained, a gauge glass can seem to show that there is sufficient water when the boiler is actually operating in a low or low water condition. Lack of maintenance may result in a stain or a coating on the inside of the gauge glass where it is in contact with the boiler water and give the appearance of an incorrect level indication, especially if the drum level happens to be outside the range of the level instrument. Be sure that all plant procedures have been followed and the control room operator is aware that a blowdown of the level instrument is about to take place. This will prevent any false trip of the boiler or unexpected drop with level indication for the primary control operator. Before conducting this procedure, inspect the installation. If any leakage is observed around the instrument or isolation valves, determine the source of the leak and make the repair. Then proceed with this blowdown procedure. The importance of proper cleaning and maintenance of the water column and the water gauge glass or level indicator cannot be stressed enough. The water column and connecting piping must be kept clean to ensure the water level in the gauge glass accurately represents the water level in the boiler. The frequency and method used to blow down a level instrument may affect service life and performance of the water column, gauge glass, or level indicator. At a minimum, we suggest weekly blowdowns on gauge glasses and monthly blowdowns for level indicators, with a maximum duration of 20 seconds. Excessive duration of blowdown time will shorten the life of the gauge glass or level indicator. However, plant rules will determine the actual frequency required. The user may also consider the quality of their boiler water as an influencing factor to determine the blowdown frequency. Furthermore, operators must consider proper blowdown procedures in order to keep the connecting water piping clean, even if the glass or level sensors remain clean for extended operational periods. Simply opening and closing the drain valve on a level instrument to conduct a blowdown will not ensure that water is flowing freely from the boiler drum through the water piping to the level instrument. However, by conducting the blowdown in this manner, the water that is in the instrument will drop and go out the drain, but there is no assurance the water leg piping between the boiler drum and the level instrument has been flushed. This is because the steam and water are both flowing from the outlet of the open drain. By following this procedure, the operator will ensure that steam and water both flow freely in this piping by testing them independently. The intent of this part of the procedure is to remove any debris or sediment from the water leg piping. While the risk of developing a blockage in the steam piping is very low, the risk for sediment buildup in the water piping is much greater over time. After following the blowdown procedure for a gauge glass or remote level indicator, the operator can be assured the steam and water connecting piping will be thoroughly flushed. We will now describe the recommended procedure for blowing down water level indicating instruments on a power boiler that's been constructed to meet the requirements of the ASME Boiler and Pressure Vessel Code. Please note, isolation valves between the drum and the water column, number 1 and number 3, are optional by code. However, if they are installed, they must be locked open under normal operating conditions. The drain valve number 5 on the water column is required by code. Using this drain valve alone is not a sufficient method to flush all the steam and water piping. This valve will remain closed during the following procedure. To begin the blowdown procedure, close the steam valves number 1 and number 2. Next, with water valves number 3 and number 4 in the open position, open the drain valve number 6, and the water will discharge. Water will be flashing due to the elevated temperature. This discharge from the water leg piping should be observed flowing out of the drain. The drain must be routed to a safe location, away from the operator. The drain piping may be routed to a condensate tank or a location away from the instrument, which may require a second individual in order to validate the flow. After 20 seconds, close the water valves number 3 and number 4. Then open the steam valves number 1 and number 2, leaving the drain valve number 6 open. Steam will flow through the gauge glass and the drain valve outlet. After an additional 20 seconds, close the drain valve number 6 and open the water valves number 3 and number 4. The blowdown procedure for a gauge glass configuration has been completed, and the indicated water level should promptly return. If the water level does not promptly return to normal, the connecting piping may be partially clogged and need to be physically cleaned. To begin the blowdown procedure for a power boiler configured with a remote level indicator, first, close the steam valve number 1. Next, with water valve number 2 in the open position, open drain valve number 3, and the water will discharge. After 20 seconds, close the water valve number 2. Then open steam valve number 1, and steam will blow through the remote level indicator and the drain valve outlet. After an additional 20 seconds, close the drain valve number 3 and open the water valve number 2. The blowdown procedure for a remote level indicator has been completed, and the indicated water level should promptly return.
Okay, how was that? Some of you were saying boring, but some of you have never seen that stuff. So, okay. Water column. So the one that was demonstrated in the video had a gauge glass and a water column. This one here looks a little different. The gauge glass is here, and the water column is here. The boiler shell is over here. Why do you think I call this one a shell and not a drum? These be some
Fire tube boiler?
Yeah, these are some fire tubes. So there's tubes inside that steam space at the top. Water should be, let's do this. Water level should be about here, which will line up with roughly the middle of the gauge glass. Let's say the water level is normally that high. Okay. So he showed some optional isolation valves here and here. This one does not have them. If the column does have isolation valves, they need to be locked open. Last thing you want to do is think you have a level in your boiler. A level is really down here somewhere, but you've got valves left shut and water trapped in this device. And we're going to skip over the video tonight where the boiler was propelled 30 meters through the wall of the building because we've seen it a couple times. But that's the kind of situation that can cause that kind of a catastrophe, okay? So this statement is referring to the water column. And what do you see on this water column that wasn't on the water column in the video? Yeah, there's three little valves on there. They're little drain valves. We'll see some pictures of them and talk about them a little more. But if you should happen to break this gauge glass or have it out of service for whatever reason, without any isolation, you should still have true reading of level in this level column. So we're connected down here to the water side, and we're connected up here to the steam side. And whatever level is represented in here will be in this column. And by opening the three, I've only ever seen 3 or 5 tricoks on a column. Basically open the one in the middle and decide if you're getting steam or air. If there's steam, go one lower, open that up. If it's still steam, your level is probably too low. In this particular one, the lowest one blowing steam would mean the water level is below the part that you can see in the sight glass, and that's the minimum level for this boiler, okay? And that would be the point where you would shut down and find out why. Boiler fittings. So all these things, up to and including the columns and sight glasses and the attention to detail that was described in the video, make sure these things are working correctly and properly, or proper operation. safe operation and protection of personnel and equipment. If you don't have a clear understanding of the important and proper use and installation of all these fittings, this is what's going to happen. I believe we all saw this video, right? Okay, the pictures of this boiler that blew itself through the wall of the looks like it's going to play itself. There's no sound, so wants to play itself. I'm going to cut it short once you see where the boiler went after the smoke cleared. Notice the date. These things still happen in the current times. Back in the day, we didn't have it on film, but most things are on some kind of a recording now. So the boiler was moved right outside the building and traveled 30 meters. Okay. So some other videos. This one is an explosion. This one has more discussion about what went wrong and what happened. Highly recommended to watch this one, 6 minutes long. There's another blowdown procedure. This is likely the one we still saw, and a couple more about low water cutoffs and blowdowns and stuff. So some good video. There's quite a few videos posted in this PowerPoint. Fittings are regulated by codes and acts because we don't like blowing the ends off of boilers and moving the boiler through the wall in the building. We really, the worst part is the paperwork. It's one thing to destroy your plant, but if you've ever been through the paperwork, it's a nightmare. So we have codes and regulations such as ASME codes. We have some CSA codes. We're not going to talk about this one very much, but we're going to learn the name of it. And the one that we're going to talk about a lot eventually in the course is B52. And you just need to understand that B52 covers certain things, refrigeration equipment, and B51 is other things. And one of the other things is the registration of fittings in the provinces. Okay, I have no idea why that happened. Feel free to, every time you read the word province, when we're talking about codes and regulations, think about the word jurisdiction, and the opposite is true. The code will say jurisdiction this and jurisdiction that. We're generally going to be talking about the provinces. Alberta has Alberta Boiler Safety Association. Saskatchewan has Saskatchewan Safety Codes Association. BC is something else. Anybody from BC here? I don't think so. And each province has its own safety agency, and the word jurisdiction is used in the codes when talking about the province. So one of the things about these codes and rules, fittings must be clearly identified. Reject the fitting if it's not clearly identified. Manufacturer's name, and this might just be a symbol, a trademark, a little picture on the fitting. Some fittings are fairly small. There's not a lot of room for all this information. Material designation can be a number from a chart. A104 is an example of a material designation. It's a certain grade of steel. And service designation has to do with pressure and temperature ratings. So there'd be 300 pounds and 600 degrees or something like that. Clearly identified. Very important that fittings are clearly identified. All right. If they are not clearly identified, things are rubbed off or ground off or not identified. People are known to buy cheap fittings with no identification. Don't use it. Just don't use it. Steam pressure gauges. Most of the steam pressure gauges you're going to see and work with are board-on tube type steam gauges. What a board-on tube is a piece of tubing with a very specific shape. In this case, in this gauge, it's a C. It's bent in a C, so the connection to the pressure or the boiler is down here. The shape of this tube is about 6 inches long. It's about the size of the tube in a normal 4-inch gauge. Maybe we should look at a picture of a gauge. So here's a normal 4-inch gauge. Inside of this housing, you'll see one of these guys. Common gauges use a board-on tube, and we'll talk a little bit more about it. These are all videos about gauges, and they're pretty good videos. They're interesting. There's use of gauges, calibrating gauges, manufacturing of gauges, and some technical ones about gauges. So this little tube that's called a board-on tube is in a shape of a C, and it's closed or sealed at the end. The cross section, or if you cut this tube off and looked in the end, you'd see a shape like this. So this is an oval shape. Okay, it's not round, it's oval. It's important that it's oval and not round. Anyone want to guess why oval is best for this device?
Expansion.
Go ahead.
It'll expand into a circle if it's pressurized, so it'll straighten out.
Absolutely. Somebody's been reading ahead. Awesome. So we pressurize this little bit of tubing, and the interior has higher and higher pressure. So this distance across the narrow width will become greater, because as we pressure it up, it will try to become circular. It'll try to look like this, and that causes this C shape to want to straighten out. Okay, it'll try to get straighter. And when it tries to get straighter, the end moves, and the end pulls on a little link, and the link turns a gear, and the gear turns a pinion, and the little gauge inside will move up the scale. Okay, board-on tube expands and straightens as internal pressure increases. Gear and sector or pinion pushes on links and levers, will move an indicator around the dial, and it's calibrated to indicate pressure. So even if you know that these gauges are graduated in usually PSI or sometimes combination, you're going to remember this for the next Thursday opportunity to remember such things. Okay. A siphon. So when we have a gauge like this, we will usually see something like this. If you walked into a boiler room right now and I said, oh, look, there's no siphon on the steam gauge, what could you tell me about that boiler? If there was no siphon.
It's a water heating boiler.
A water tube boiler. Yeah, that's correct. So what does a siphon do? Let's talk about what. Siphon is an essential fitting. So language like essential or shall have means it comes from some kind of code or regulation. This is where our boiler shell or drum would normally be connected to this little valve here. This is the siphon or the pigtail, something called an inspector's test connection, and the gauge would sit on top. Board-on tube doesn't like hot steam inside of it. Okay, it's small, it's flimsy, it's fairly delicate. So when we have a piece of pipe here between the hot steam and the gauge, it will cool enough of the steam in to condensate, and this loop will fill up with water. And then we won't have hot steam inside the gauge. Okay, just water. Some other controls that are pressurized will also have pigtails or siphons between the gauges. Okay, this one represents the water level in the siphon.
Hey, Kevin, a quick question.
Go ahead.
On the siphon tube or pipe or pigtail, is it installed pre-filled with water, or are we assuming that the steam and the condensate is gonna accumulate quick enough not to damage the gauge?
I'm pretty sure if you read through a fourth class textbook, it tells you to fill it up with water. And I've seen procedures in books and textbooks. Get a pail of water, fill it with water, and then at least you'll have a bit of water in here to get things started. And I've seen the other way around. I've seen where somebody just looked at me funny when I said, shouldn't we fill it with water? It's as the steam pressure, if you're putting it on a really hot boiler, I'd recommend pre-filling. If it's sitting there through a summer shutdown and And you don't fill it with water when you bring things up. It's gonna cool enough steam to have water in it long before the pressure and temperature is going to be damaging your gauge, right?
Okay, thank you.
Pipe siphon maintains a water seal between the steam and the boiler, and the board-on tube fills with water. It will still transmit the pressure correctly into the gauge to prevent, its purpose is to prevent the entry of buds. So here's a siphon. Here's a gauge with a siphon on it. We're going to talk about later the inspector's test connection. What is that for? Here's some gauges. Here's the one you want to remember, graduated in KPA. Here's the one you'll probably see if you're familiar with gauges in your plant. Gauges that are called compound gauges will actually read, notice this one is calibrated in KPA, but 0 is here. So it'll read pressure above 0, and it'll also read pressure below 0, and we call that vacuum. And the one over here is PSI. So 0 is here, so we can read pressure up to 30 PSI, and we can read vacuum down to 30 inches of mercury. Okay. This is the one we're going to remember. Gauges are calibrated and are graduated in kilopascal. Testing a pressure gauge. So these things are delicate and fragile, and it's actually amazing the abuse you can put one of those gauges to. But with hard work, you can make one lose its accuracy, and every now and then you need to test because you don't know what how everybody has treated your gauge. Your boiler requires a pressure gauge. There's going to be some instruments feeding pressure readings off to control rooms and BMS panels, boiler management panels and stuff. But the gauge on the boiler is very important to be sure that it's accurate, so that you can have a safe operation. So some methods to test that. Place an accurate gauge on the test connection. So you have a spare gauge in your pocket. A good operator might have a digital test gauge. This is a thing now. It's kind of newer technology in your tool pouch or whatever, or in your tool room. If you doubt the accuracy of a gauge, if you're trained to use the gauge, and you have the connections like this and the valving like this, you can isolate that connection and add your gauge here and compare this gauge to the one that you were unsure of. And that's called a comparison test. If you really wanted a super accurate gauge, you were going to be testing the popping point of your tester of your safety relief valves. You might call in some professionals, the instrument mechanics, and they may take your gauge or a new gauge out of the shop and put it on something called a dead weight tester or a hydraulic comparator and make sure your gauge is deadly accurate. And then they bring a gauge to you and you can swap them out and they can check and calibrate the one you gave them. Okay, but these are used by trained personnel. That doesn't mean that you wouldn't get pressure gauge training as an operator. That certainly is allowed. Okay. Testing a pressure gauge. So testing by using another gauge on the test connection as test gauge comparison. And deadweight tester, hydraulic comparator, these are other methods, and some basic training should be involved for the use of this. I just noticed I don't have my big glass of water, but I'll just take off in a few minutes and get it. Maybe I'm going to do that now because we're moving into safety valves. So I'm just going to grab my water. I'll be back in 30 seconds, folks.
How you guys doing?
How's everybody doing? All good? Good speed? Good detail? Clear as sledge in a mud drum? All good. Okay, every boiler. Safety valves apply to every boiler and a lot of other things. This is a very important piece of equipment. Designed to operate below a specific maximum pressure. So maximum allowable working pressure will come up. It will be MAWP. I'll be highlighting that when we see that. And these devices are designed to protect boilers and other equipment, piping and vessels and exchangers from overpressuring. Things can happen, things can go wrong. You can lose the load. Automatic valves can fail, any valve can fail. And all these things can cause overpressure. And when things are getting close to that MAWP, maximum allowable working pressure, we want to make sure we don't burst the boiler drum or other pressure parts due to this excess pressure. So if you read some boiler codes and regulations and rules, you'll see at least one pressure operated safety valve is installed on each boiler. And that's one per each small boiler. As boilers get bigger and systems get bigger, there's going to be more and more safety valves in your system. What does a safety valve look like? Standard issue safety valve looks something like this. Here's another couple of pictures of a safety valve. If you've worked around boilers and in plants, you've seen these. There's also tinier versions. We'll be looking at them yet. So on the left, we have a cutaway safety valve. And on the right, we have a diagram of a safety valve. Some common features of most safety valves, a tri-lever or an easing lever, something that you can grab onto and pull. This is actually a device that allows you to open the valve. Pull up on the stem. Stem is in the middle, in the center of a large spring or a small spring, small safety, small boilers have small safeties. Internally, there's a disc and a seat. This is why we call it a valve. A valve has a disc and a seat. The disc sits in the seat and closes off an opening. So the bottom of this is the inlet. This is where it would sit on top of the boiler. Pressure is going to be pushing on this disc where it says D valve. Pressure is going to be pushing on that, and the pressure created by the spring is going to push the disc down into the seat. And under normal conditions, pressure is lower than the specified opening pressure. This thing would be closed tight. Okay, a couple of examples. So our safety is going to sit upright on top of our boiler shell or boiler drum or other pressurized piping. Safety valve is normally mounted on top of the steam space of the boiler. So we're going to talk about safeties on steam boilers. Much the same on hot water boilers, but some important differences. So the force created by the steam, and the steam force or pressure comes from the bottom here up into the disc, is a function of the disc area. So if you have an area of a disc that's 2 inches in diameter and you have 100 PSI pressure pushing on that disc, it's going to create a certain amount of force. And if that disc is twice as big, it's going to create twice as much force. So if you have a small disc and a spring on top of it versus a larger disc that would create more force, you would have to have a larger spring, or adjustments are made in here to make a greater force downward to hold this disc against the seat to keep the valve shut. Force created by steam is a function of the disc area. So if you had a small boiler, you would see something like this, about 6 inches tall. If you had a very large boiler, this guy could be 6 feet tall. Okay. Bigger pressures, bigger forces, you're going to have a bigger spring to create more force to push down against the disc. How does this all work? As we increase steam pressure in the boiler, it will eventually overcome the pressure of the spring on top of the disc. So this spring is pushing down, and this disc is pushing up. So the bottom diagram on the left shows the area of the disc exposed to steam when the valve is closed. And then the next two pictures show the area of the disc exposed to steam when the valve starts to open. So have a look at the purple seat in here carefully. The purple disc. So the purple part in this diagram is the disc. And notice that the green parts below it are the seat. And notice that they're closer to the center than the edge. Okay. So the area that's exposed to steam pressure is this smaller area between the two sides of the seat. The disc is larger, but the outside lip, is it labeled lip? It's not labeled lip there, but we'll talk about that lip. The lip is the difference from the inside of the seat to the edge of the disc. When you look at the diagram at the bottom here, this includes that area around the outside. So it's actually almost double surface area exposed to steam. Should equilibrium be passed? So I think we mentioned that briefly in our mechanics discussion in the first week. What is the meaning of equilibrium? Equilibrium means everything's balanced. Nothing's going to move. Forces are there and things are going to be thinking about moving, but right now at equilibrium, they're going to stay still. The pressure below the disc is creating less force on the area of the disc than the spring pushing down on the top. We have equilibrium, the valve stays shut. If we continue to increase the pressure and go beyond equilibrium, the disc will lift off of its seat. Steam is suddenly released around the disc, and that occurs at something called, normally it would be set pressure, but has been referred to as blow-off pressure. Okay, so at set pressure or blow-off, I'm going to throw another term in there, means the same thing, popping pressure. Steam boiler safeties are popping type safeties. They remain closed until they open. Once they open, they pop. They literally open wide immediately because of this process that we're describing. The escaping steam strikes a lip around the disc, increasing the area of the disc subject to steam pressure. So there's a certain amount of force pushing on the small inside part of the disc. As soon as the steam escapes past the seat, it now pushes on that larger surface area, doubling the amount of force instantly. So when the force is doubled instantly, forces the valve wide open, causing it to pop. If you've ever heard a safety pop, 100 pounds and above, 100 pounds, 100 pound steam safety on a header in a small lab, a small boiler room like the lab at Nate, you think a car drove into the brick wall. Okay, you know when your safety pops. When 3 or 4 600-pound safeties pop, or 1,500 pound safeties pop on a large steam system, the building shudders like a railway locomotive drove into the corner of the building. So it's pretty obvious when your safety pops. Okay, there will be paperwork. So the sudden, how's everybody doing? Are you following that? We have pressure, we have force, we have a spring. There's two forces keeping in equilibrium. Pressure gets too high, passes equilibrium. A little bit of steam escapes, doubles the area being affected. Force increases, safety pops open. You hear a heck of a bang out there in the plant. The pipes will shudder, the dust will come down off of the pipes, and plaster will fall out of the ceiling. Houston, we got a problem. We blew a safety. Okay, we went beyond that last line of defense for overpressuring our equipment. Lots of things should have happened before that. It won't happen very often, but we need to have this safety if all the other things don't work right. Okay. Sudden increase in area under pressure makes the force much more unbalanced, causes the valve to pop wide open. Escaping steam strikes the lip around the disc, increasing the area of the disc subject to steam pressure. And we have a video, if I can get it. I think this one. Maybe I can get it. Or not. Let's do this.
Let's begin with a look at the basic components of a typical spring-operated PSV.
First, the spring, the spindle assembly, inlet, outlet, and the pressure adjustment screw. In operation, inlet pressure exerts a lifting force on the spindle. This lifting force is reacted against by the downward force of the spring. If the inlet pressure is increased to the point where the total upward force overcomes the spring force, the valve opens.
Okay, pretty straightforward. And if you're not too clear on how they work, just have a read through that stuff again. It starts to come together. We're going to review it. We will review it a few times and look at variations on the theme. Eventually you'll get it. Would you, as a worker in your plant, now that you've seen a couple pictures of safety valves, go out and start messing around with these adjustments? Everybody say no. Operators will typically not be adjusting. If you are caught adjusting a safety valve, if you do get a ticket after this, you're probably going to lose it. Okay.
You'd have to, sorry.
Go ahead. What was the comment?
I was just going to say you'd have to break the seal, the service seal.
That's right.
And then the valve's actually no good no more.
That's right. Yeah, adjustments done by trained personnel. And this is the safety valve guys, the safety valve shop. So specifically trained to adjust safety valves. Compression of the mainspring will increase downward force on the disc. So if we're going to tell the trained professional how to adjust the valve, you could tell them increase the pressure so that the blowing or the pop off pressure goes higher. Okay. Always adjusted by qualified people. Compression of the mainspring increases downward force on the spring. So just so you understand the workings of it, okay? More downward pressure will take more boiler pressure to pop the safety, and the opposite is true. When this is done, it will be sealed. So to do those adjustments, you would have to break the seal, and it is illegal for you to break that seal unless you're trained and qualified. If you do, one of the first things you'll find on a boiler startup checklist and other pressure equipment startup checklist will be check the safeties. You'll look at the tag. There's no tag and no seal. You won't be starting the boiler. You shouldn't be starting the boiler. So adjustments only done by trained personnel. Now what? After it's popped open, the pressure has come down, should come down very quickly. Closure of the valve occurs after pressure has dropped several pounds below the set point. This is due to the increased area. Seeing the steam pressure after the valve unseats. To ensure tight closure, maximum operating pressure should be set several pounds below the set pressure. So there's a difference between opening pressure and closing pressure. Opening will occur if your system safety is set at 110 pounds, for example. Your closing pressure will likely be something like 95. And this is something called, it has a special term for it, and that comes up in the next slide. Here's some recommendations from manufacturers. These are the guys that decide these things, how much below, what he set it at. So if we were to play around with a safety valve and adjust the difference between opening and closing, we would call that regulating the blowdown. This is not the blowdown that's done to level columns and boiler drums. When we talk about regulating the blowdown or safety valve blowdown, we're talking about the difference between the opening pressure and the closing pressure. This is called the blowdown of the safety. Okay. Another two methods that we're going to talk about to test the safety valve. Two ways to check that it's going to be operable for us. Something simple and easy and common is called a lift test. I showed you pictures of a couple of safety valves. They had tri-levers or test levers on them. If you got a little safety on your water heater in your furnace room, you'll see a little tri-lever on there. You may have gone by one someday, sometime, and pulled on that lever and got your feet very, very hot and wet. It's simply a tri or lift lever. The textbook recommends doing one of these tests monthly. Your facility will be different than that, probably. Most boilers that I've operated, the lift test is on every startup. Not necessarily something you do during operation for fun, unless there was an issue or problem. We'll talk about what kind of issues would initiate a lift test. So the safety can be tested by operating the lever to allow steam to escape for 5 to 10 seconds. Now, this is a big boiler and high pressure. It's going to be quite an operation to physically actually blow the safety. So not something you just want to do for fun. Perform the test after boiler pressure is up to a minimum of 5 psi. If the valve continues to leak, you might have to do it a few more times. When you do a lift test, you might get scale come loose and get trapped in the seat, and then you have to clean that out of there. Another test is called a pop test. Pop testing a safety valve is actually raising the pressure in the boiler. So it's a procedure, it's a process. You're going to let your panel operator know, you're going to get somebody to help you, you're going to make sure your steam pressure gauge is accurate. You might connect a second gauge just to do this test to see that you have correct readings and knowledge of the pressure when you're messing around with raising the pressure up to that popping test. Pop test is to raise the pressure of the boiler with the discharge valve closed, accurately observe the pressure gauge. So somebody needs to be watching the pressure gauge as you manipulate things to make pressure come up. If this safety valve is up 11 or 12 floors up in the rafters, you may need to be up there to visually verify that it's opening. Controls might be in manual or overridden. So this is looking at a heating boiler with a maximum 103 kPa or 15 psi pressure. Safety should open within 2 psi of that setting. Observe and record the pressure. If the valve sticks or doesn't reseat, continues to leak, if you're doing a pop test, now you're in a position where you must take that boiler down and have that safety repaired. And that being said, I will show you where some installations can have alternate safeties. You can have a safety and a shuttle type valve where one safety is commissioned and not the other. If that safety does fail your test, you can switch to the second safety and keep running. But that safety needs to be sent to the valve shop, to the safety valve shop. So a little review. Method number 2, the pop test. We're going to ensure the gauge is correct. Make sure you have an accurate reading. Conduct a pop test by actually increasing boiler pressure slowly, safely, carefully, until safety valve opens. Note the pressure on the gauge when the valve opens. If you determine the safety, you go up exceeding that pop pressure and it doesn't open, you're also in a position to shut down the boiler and have the safety repaired or replaced. These are all 3 important points. ASME recommends repair and adjustment. Safety valves only by trained people. Authorized inspector will attach a seal to a safety valve. This is to prevent any operators from doing adjustments. None, no midnight maintenance not allowed on safety valves. And if you do tour around your boiler and see there's no seal on the safety, you better be talking to management and thinking about shutting down. If an inspector were to arrive on your site and find no seal or a tag, a valid tag, inspection tag on your safety, he'd be shutting you down for longer than you'd be down for if you initiated that on your own. Back to our gauge glasses. During operation, water level must be high enough to cover all parts of the heating surface with water to prevent overheating. And we'll look a little closer at this. So this gauge glass is connected to a boiler shell in this case. This gauge glass is connected directly to the shell. Note the location of the bottom of the gauge glass relative to something called the lowest permissible water level. So a boiler should be marked with things like lowest permissible water level. Notice that this is a certain distance above the upper heating surface in this boiler. Okay, this distance here. And then code recommends lowest visible part of gauge glass is actually a little higher than the marker, so 1 inch above the lowest permissible water level. So when that water level hits the bottom of the gauge glass, you need to shut down. Okay. Do not be running with no water in the gauge glass. Purpose of a gauge glass, physically show us the water level. So the lowest visible part of the gauge glass will be above the lowest permissible water. Okay. And this shows the lowest visible here in the glass and lowest permissible. This one we have 25 millimeters above the top tube in the boiler. There always must be level above the heating surface. Keeps it cool. If it is not cooled by that little bit of water, it's going to overheat and cause damage. Could be catastrophic. If we operate at lowest permissible level, no danger of overheating. But if we go below lowest permissible level, we need to shut down. Some gauge glasses are kind of flimsy looking affairs, but it's important that they're set up with the correct minimum level compared to lowest permissible level in the boiler. If our gauge glass starts to blow steam or water or both, should be both, first action is to isolate the valves. Sometimes gauge glasses come with water columns. Some important reasons why we would have a water column. More flexibility in where these connections go. So the placement of this gauge is more variable with a water column. It will also dampen level fluctuations. I'm going to recommend to you tonight some videos. They're in one of the chapters that show a boiler with a camera inside, so you can see the things going on. One of the things you're going to notice about water level in a boiler, it's not calm. It's not cool, calm, and collected. Okay, nor does it stay cool, calm, and collected. This can be pretty wild in here. So when water is flying around and you have this kind of a gauge glass, you can see some activity in here. So kind of hard to say the level is here or is it here, right? You're going to see this bouncing around. So in bigger boilers with much more activity in here, we're going to have a column. And one of the specific reasons for the column is it dampens those fluctuations. So even though we have water level doing this over here, we're going to see a kind of an average in here, right? And the other thing about a column is it traps sludge and sediment, and we discussed the tricox, the 3 valves on there. So we have this this ability to check the level should this gauge glass break, and we isolate it. As long as we have this ability to check the level, there will be other level indicators, but we need something that's physical plus the instrument. And this is a physical level indicator. Okay, we can physically open the bottom valve. We should have some water coming out of it. If the bottom valve blows steam, the level is below the bottom valve, so the level's too low. Okay, if we have some water blowing out of the bottom valve, and then mixed steam and water in the middle, and then steam out of the top one, our level is going to be pretty close to where we need to have it. And trapping of sediment and sludge. And you saw that in the video that we can blow that down once in a while to ensure we don't get this plugged up with sediment. And tricox were once required by code on many boilers with a column. And apparently that code has been rescinded. They're not necessarily having tricox on the columns anymore. If you don't have those tricox, you're not going to have a way to check if your gauge glass breaks. And this will basically be the video we watched, the testing the connections. So close the water valve. So gauge, in this case, we're talking about the level gauge, level column. Okay. Gauge glass breaks, isolate the block valves on the steam and water side. The textbook has a procedure for changing the glass when we have a breakage of the gauge glass. You can have a look on page 519 and read all about it. Placing a gauge glass tube, the tricox to check level if necessary. Some of the fittings on boilers are simply valves. We have different kinds of valves. We'll go into greater detail about different kinds of valves in a chapter on valves in book 3. Book 3 has valves. But a couple of basic types, a globe or a plug valve or a gate valve. Just going to remind, we're just going to briefly talk about globe valves. So this globe valve has flow direction has to change going through, and it has a globe or a disc and a seat at right angles to the flow. And this one is a good style of valve for adjusting flow. Gate valves are typically going to be just isolation or stop valves. So when closed, a gate moves into the piping and blocks off the flow. And if we run this valve partly open, it's going to erode and wear on that gate. That's not going to work very well. So it's designed to be closed for full shut off or wide open. Okay. And you can have a little closer look at the differences here, but we're going to have a greater discussion about globe and gate valves in other chapters. Check valves. Check valve allows flow in one direction. Check. So stops the flow in one direction, allows the flow in another direction. Stop valve acts as an isolation valve. Yeah, sometimes gate valves are referred to as stop valves or isolation valve. Check valves can be 2 types. We'll briefly look at that. Feed water valve can either be globe or gate valve. If it's called a stop valve, it's probably going to be a gate. And globe valve allows throttling and is really the only valve suitable for throttling in most cases. There are newer materials now, and we'll see a lot of types of valves that we would never use for throttling in the past, used quite a lot. Example, ball valves. Check valves, flow can go to the boiler, and should our feed water system break down or not drop in pressure for some reason, we would have a check valve close off. And this is a lift check valve. This flow will hold this lift or flapper open, and then reverse pressure will push it closed. As opposed to a lift check, this has a damper or dash pot. When flow pushes the lift check valve open, it will not slam open and slam shut. It will be gently closed and gently open because of the dash pot. So we talked about blow down on a safety valve. We're now going to talk about blow down that means something completely different. Lowest point of a boiler or other chamber or vessel, such as the drums we looked at in previous chapters, or level columns we looked at tonight, they will have some kind of drain or connection called a blow off or blow down point. We can drain the boiler, we can blow out mud and sediment. Sometimes we do that just to get rid of sediment. Sometimes we need to lower concentrations of dissolved impurities in the boiler water, and this process is called blow down. This is not the same as blow down on a safety valve. Blow down on a safety valve is the difference between popping pressure and closing pressure. Okay, safety valves will open at a higher pressure, below the pressure down, and then close. And the difference in those pressures is called blow down of the safety valve. Blowing down a chamber or vessel is a different definition. When you have these connections on boiler drums and things, you'll often have double valves, one that's quick opening and one that's slow opening. There's a procedure described on 526 in the textbook. Basically means we'll open up the quick valve first, we'll then open the slow outside valves and slowly blow down our boiler. And then to close, we're going to close that slow opening valve and then close the inside valve. And this is to prevent one valve or the other from becoming eroded by the flow, by the blowing down, by the pressure, in which case we'd have to shut down the boiler and replace that valve. When you use a double system like this, you extend the life of these blow down valves. A vent valve. So we're looking at a chapter that's called Fittings for Steam Boilers. So notice our steam gauge is a siphon that's labeled a steam gauge. We have steam coming out of our boiler. We have a stop valve. We have pressure relief safety valve, a water column and a gauge glass. We've got a feed water system with a check valve and a stop valve. Here's our blow off drain from the bottom of our boiler. Here's our blow down drains from our column and gauge glass. And what you're going to find on most boilers is a vent valve, some way to open up the atmosphere. Not required by code, but most boilers will have one. If you don't have the vent valve, you're going to have to be taking off some fittings apart to allow air to escape when you're filling the boiler, to allow air to into the boiler when you're draining it, and then to allow air to be freed when you're heating new water filling up your boiler. Gauge glasses might break in service. What would break your gauge glass? One of these is true. Okay, we've got a thin tube of glass, partly filled with water. Level is moving up and down, so there's some steam huffing and puffing in the top section here. Occasionally, we're going to blow steam down through that gauge glass to ensure the piping is clean and the gauge is clean and everything's operating. Eventually, we're going to thin the glass. These can be pretty flimsy devices. Bourdon tube, what is the shape? It's a big C. And what is the shape of the section? It should be some kind of an oval. Okay. Pressure will make it fatter. Pressure will make it rounder. And when it gets rounder, it's going to cause this vent tube to straighten out. Okay. And that'll give us a representation of the pressure when it moves the needle over across the scale. Okay, this tube straightens out, pulls on a lever, makes the pointer move up scale. Opposite is true. When the pressure goes down, the section goes back to normal and needle will move down scale. Gauge glass safety shutoff valves. So I didn't talk about this when we saw it before, but some of the valves on gauge glasses It's a code requirement for gauge glasses on receiver tanks that hold refrigerant. But it's also common on safety shutoff valves for gauge glasses on the boilers. And what's unique about this valve? It has this little stainless steel ball bearing inside. So if this valve is wide open, it allows the flow in and out of the gauge glass. Level can go up and down should the glass break. And then the increased amount of flow tries to blast through this valve. This little stainless ball will act like a ball float in a shot vac. If you use your shot vac to suck up water, when the water level gets too high, there's a ball in there that floats up and closes it off from blowing water through the electric motor. Hydro, a hydrostatic test. Hydros are done at 1.5 times maximum allowable working pressure. Okay. Purpose of a gauge glass. What is a gauge glass designed to show us? Not the pressure, not the color. Some gauge glasses do have colored indicators, but that's not the purpose of a gauge glass.
Water level.
Yeah, something to show the physical presence of the water level. Okay, we can have all kinds of instrumentation. We can have nuclear gauges. We can have some high pressure boilers actually have nuclear gauges to tell you the water level inside. But in addition to the instrumentation, we must have a physical representation. So you're going to see some kind of a gauge glass on almost every boiler, all right? And nothing to do with steam temperature. Fittings shall be marked. Fittings shall be legible, or markings shall be legible and indicate three things: manufacturer's name, it might just be a trademark, service designation, and material. So material is, what is it made out of? That's easy. Is it alloy 120, stainless, carbon steel, high stainless steel, high carbon steel? Service is a couple of things. What two things come under service? Pressure and temperature, okay? And material, manufacturer, service, and material. Blow off or blow down connections. So in this O-type boiler, where would you have a blow down connection? Other than on the
Lowest point
Mudroom?
of the mudroom.
bottom of the mudroom. Lowest point of the mudroom. Okay, and then we'll see that here. So sometimes we blow down boilers a little differently. This is called intermittent or periodic blow down. And interestingly, I see an automatic valve on here. Generally, it's the valves I showed you, the quick opening and the fast opening, and it's a completely manual process. Sometimes it's automated. And there's another place to blow down a boiler, and that's called continuous blow down. That's going to be just below the water level. In a chapter on water treatment, we'll talk about the dirtiest place in the boiler. You might think that's down here, but actually, because we're boiling this water, some of the dissolved thing or suspended solids will collect up near the surface. So we can control that kind of collection of stuff in our boiler water with continuous blow down. So that's also called blow down. Okay. I'm going to come around the back. The gate's still open. I didn't close it. Sorry, folks. With the construction outside, people are having trouble finding their way to our house. Water main blew up 2 days ago. I will have a shower when they turn it back on. Quick closing gauge glass valves. So if you see valve that looks like this with a lever on it. I know a lot of you know what that's all about. It's quick closing. So how many turns to close a quick valve? How much of a turn to close a
Quarter.
A quarter. So I want you to explain to everybody, it's not a half. There's no such thing as a half turn valve. Okay. This gets picked on every exam by 70% of the students. Not a half, it's a quarter.
turn, 90 degrees.
It's 90 degrees, yeah. If you remember 90, it's really easy not to get this answer. What are these guys? They're little drain valves. What are they good for? Not for this. Shouldn't. Drain is not in the answer.
Boiler water level.
Check the level. Only to check the level. The draining of the column is done by the drain connection. Okay.
Texting Cadwell is teaching.
Okay.
He's texting Cadwell, he's teaching, so we don't know that she's still.
Can you not just follow her, please? Leave me out of it. Sorry about that, folks. Miscommunication. Okay, steam pressure gauges are graduated in, pick one.
Kilopascal?
Yes, correct. Okay, as much as you know otherwise, this is the one you're going to be asked about. All right, little bit of a review of chapter 5. Essential fitting between the steam and pressure gauge.
A siphon.
Siphon. No gate valves, no check valves, no steam drums. Siphon. Correct. Why a siphon?
Gives a chance for the steam to cool and fill it with water.
Yeah, the aim is to keep the steam out. Okay. Okay, none of these others apply. Prevent water. Oh, sorry. Yeah, no, wrong. Prevent water from entering the gauge. Sorry about that. So a siphon might look like this. Okay, it doesn't have to be a pigtail. It just has to be a low point in the piping. So this one's called a U-tube. They still call it a siphon, but a U-tube type, not a pigtail type. Test connection. What is a test connection for?
Test your gauge.
Yeah.
See if it's accurate.
Install the boiler's inspector's test gauge. Okay. Yeah, install the boiler inspector's test. Blow down of a safety valve. One of these is true.
The difference between opening and closing pressure.
Correct. The difference between opening and closing. What prevents tampering with a safety valve?
Safety seal.
A seal, correct. Increase safety valve opening pressure. How do you do that?
Increase the spring compression.
Yeah, more force down requires more force up.
Let a trained professional do it.
And bingo, only by trained professional. Force of steam pressure on the safety valve disc is a function of.
The disc area.
Correct. Thank you. The lip on the safety valve disc, so the little area that's bigger than the seat, is called the lip. And this is what does one of these three.
Causes the popping action.
Correct. Thank you. If a safety valve leaks after you've done a tri-lever test.
Operated several times to blow away the foreign material.
Correct. So this is a pop test. Increase pressure until the valve pops, okay? If you find the safety valve is not gonna pop open or be pulled open, one of these,
Shut her down and replace it.
shut her down, boys. Houston, we have a problem. Unless you have a ability to switch safeties. Prevents water or steam leaks if a gauge glass breaks. That's the safety type. I got this backwards. Safety shut-off valves. So they're the ones with the little stainless ball in. We didn't talk about this. Who read about the material used for what?
The water column.
Water columns are cast on lower pressure boilers, okay? Dampens water level and traps sludge.
Water column?
Water column, correct. If a gauge glass breaks, first action,
Close the gauge glass isolating valves.
correct. This is a repeat. Try Cox to check water level. Here's some more videos for you. All fittings must be clearly identified with three things. Service is pressure and temperature. Name or trademark. What is the material? What kind of material? This is a video, a little short video we watched. Some of the quiz questions in the book I will recommend. This chapter has pretty good ones. Somebody needs to mute. I can't see who it is. Rashir?
Mr. Ken, I have a question.
Yeah.
When we collect a water sample from the boiler, it must be clear or colored?
I would like to see clear, but it depends on what are you sampling on a routine? You're talking about routine samples, daily samples?
Yes, monthly checking.
Only once a month?
Yeah.
Might not be very clear.
Okay. And is it need a immediate attention on that, or?
Well, you need to be doing the right samples. So if you have a water testing contractor, you better call them in if it's not clear.
Okay, thanks.
And you know, there's specific situations. If you're just taking a random sample, it might be a bunch of stuff collected in the pipe, but generally you want clean water in your boilers. Some boilers are not going to be as clean as others, but your sample should be that continuous blowdown.
Mm-hmm.
And it should be clean when you go to take a sample. It should be running all the time, right? All right.
Okay. Yeah, thanks.
Okay. Okay, folks. I'm just going to take a 3-minute break here. I have to clear up some communication problems, and then I'll be back. So when I come back, we're going to look at all the same fittings. So a little bit different discussion. It'll be a good review, but we're going to talk about the differences between hot water boilers and steam boilers. Some different fittings on hot water boilers and some different applications of the same fitting because of the different type of boilers. I'll be back at 5 to 8.
Body. Right.
Bale.
Kemargaan balik.
So I was gonna look for a little video, but maybe I'll show it next Tuesday. I don't know how many of you remember playing whack-a-mole. So before games were video, they had actual games where gophers would pop out of a machine and you had to bash them back in. So if you've got things going on in your room, folks, kids and dogs and things, I'm muting you. Don't unmute yourself. Learn how to stay muted. Make sure you're muted, please. Okay. How's everybody doing? Good. Right on. Happy. So basic fittings for hot water boilers. And this is, this is not everything and anything, but it's all of the important stuff. And some of it's going to be repeated. It's the same fittings. Hot water boilers. So who can see a piece of equipment on this drawing that we may not have seen on a steam boiler in the last?
Thermometer?
Thermometer. Yeah, good catch. Where did you see it? I don't see it.
6th grade.
Okay, I know it's one of the things on hot water boilers. So what I was getting at is, look, there's a cushion tank or compression tank or expansion tank. So you never see that. You never see that on a steam boiler. Okay, steam compresses. So we've got compression space in our steam drum. So unique to hot water heating systems, something called an expansion tank. Back in the day, we had open tanks on the roof of the building or up in the attic. That was kind of tricky and inconvenient. Newer technology developed something called closed expansion tanks that are much better. They could be closer to the boiler, less likely to overflow them and flood the whole darn place. And newer technology that was very new when they wrote these books is called a diaphragm type, and a lot of systems will now be converted to diaphragm type. I don't know that. Doesn't make sense to me that very many systems, unless they're really old and under-maintained, would still have this type. But we're going to talk about all three. Most of the stuff in the textbook talks about this one, and but we will look at all of them. Expansion tank can be called cushion tank or compression tank. The new diaphragm type can be called bladder type. So basic fittings for peculiar to hot water boilers. Essentially, hot water boiler must have a pressure gauge. Sometimes the pressure gauge on a hot water boiler is called an altitude gauge, and we'll talk about what makes it that we call it that. Something called a thermometer. Yes, temperature is always important, but on a hot water boiler, we're more likely to have temperature indicator, and it's often called a thermometer. Safety relief valves or pressure relief valves will work a little bit differently. They don't have that popping action because we're not using steam to. The use of steam requires that they pop open. If non-compressible water needs to be relieved, it can relieve without that popping action. Isolation valves, stop and shut off valves, expansion tanks, sometimes called compression tanks, sometimes called cushion tanks. The three types: open type, closed type, and diaphragm type. So here's a altitude gauge. It's really just a pressure gauge with a movable pointer, and the pointer is set to indicate something that we'll describe right away here. And sometimes the pressure gauge on a hot water boiler has a combination, temperature and pressure on the same gauge. So to indicate pressure in a hot water boiler, pressure or altitude gauge shall be connected to the boiler or close to the outlet header. Design is same or very similar to steam pressure gauges, but no siphon is required. The whole system is full of water, needs to be full of water, should be full of water. No need to isolate the gauge from hot steam. And the scale on the pressure gauge shall be graduated somewhere between 1.5 or 3.5 times the maximum allowable working pressure. Pressure gauge on a hot water boiler. If you walk up to a boiler and you see, you can't see yet whether there's an expansion tank or not, because it could be old school open type way up on the roof of the building. If you see no siphons, you can be pretty sure you've got a hot water boiler. So the pressure or altitude gauge, just like on the steam boiler, indicates the pressure. We set a pointer at a distance equivalent to the height of the system, plus about 1 meter or 4 feet. And then we'll talk a little bit about why that is. Sometimes it includes a temperature gauge like this one does, and no siphon is necessary. So screwed right into the boiler or near the boiler. Temperature gauge looks like this. This is what we used to call a thermometer. And you can also put in the typical round dial temperature gauge and call it a thermometer if you like. Safety relief valves. So safeties on a boiler, PSV, pressure safety valve, pressure relief valve. Hot water boiler safeties work pretty much the same, look a little bit different. Installed on the boiler or close to the outlet because it's containing water, it's not so critical. Steam boiler, PSV sits right on the top of the steam space. Stop or shut off valves, isolation valves installed on supply and return piping in case we need to drain the boiler and we need to keep the system, heating system full. Open type expansion tank, so old school with a vent to the atmosphere connected to our system, but needed to be above the highest part of the system. Any expansion tank is there to allow for expansion of water in the system. Okay. Closed type will possibly look like this with a gauge glass on it. Closed type expansion tank should be partially filled with water and partially filled with air. And, rule of thumb, half and half. Diaphragm type will be partially filled with water, partially filled with pressurized air or other gas. Sometimes these are pressurized with nitrogen. Has a diaphragm inside connected to the system, hot water system, fills up when the water expands into the expansion tank and then pushes the diaphragm and creates a pressurized pocket of air to allow for that expansion and contraction. And these are called the diaphragm tank. Okay, this is a closed type expansion tank. So it's generally sitting above the boiler, has the gauge glass, has a drain, might have a vent, probably has a vent, but vent is normally closed for operation because we want partial air and partial water in that expansion tank. Here's something else you'll see on a hot water system you won't see on a steam system. Steam will push itself down the line, and hot water needs to be pumped and circulated. Closed type expansion tank, generally equipped with a gauge glass. Expansion tank attached on the supply main, so we're supplying hot water out to our system. This is where this expansion tank is connected. Relief valve, if not directly on the boiler, it could be on this outlet pipe, but close to the boiler. No siphon required between the gauge and pressure gauge and boiler. Kind of a little review: pressure, altitude gauge, a thermometer, safety relief valve or pressure release valve, stop isolation valve, different kinds of expansion tanks, some controllers. Oh, this is not a controller, sorry. Looks complicated. It's just our altitude gauge. We set the pointer, and this one happens to have the temperature reading. Each hot water boiler shall have a thermometer located at or near the boiler outlet. We want to know the temperature supplying the system. So the temperature near the outlet or on the outlet means we're going to show the temperature of the water going out of the boiler. Could be linear or circular. We looked at those. There will be other temperature indication if you have many zones being supplied. Each zone will have inlet return temperature. And you can compare what's coming back to what's going out from the boiler. Okay, combination gauge with your built-in temperature. Section 4, this is the section of the ASME code that covers heating boilers. States that each hot water heating boiler shall have at least one officially rated pressure relief valve. And pressure relief valves are always set at or below maximum allowable working pressure. On a hot water heating boiler, that would be maximum 30 psi. Typical safety relief valve will have two ratings, one for maximum pressure and one for how much relief capacity. Pressure relief valve opens partially when boiler pressure exceeds valve setting. These safeties won't pop like a steam relief valve. If pressure continues to rise, the valve will open wide, and the relief valve will close when the pressure returns to a safe level. Relief valve should be installed on the boiler or close as possible to the boiler outlet. And something important is there shall be no shutoff valves between a relief valve and hot water boiler heater or tank. Ruptured diaphragm in the expansion tank or flooded expansion tank will cause a relief valve to leak when the boiler is fired. So you'll see some water coming out of your safety. Passing relief valve should be try tested, try and blow it clear. And you'd be surprised how many times I found a plug in this guy on a hot water heater. Okay, oh, it's leaking. Oh, something must have fallen out of there because it's just a threaded opening. Back in the day, they didn't have any pipes connected to this. And if it started to leak, people would put a plug on there. Look up hot water heater rockets, Mythbusters. They put those hot water heaters right out through the roof with not having a safety. Temperature relief devices, temperature pressure release valve. So this is a combination device. If you take this guy out and you notice that it's got a rod on the bottom here, this also reacts to temperature. protects the system from high water temperatures and will open when temperature rises to 99 degrees C. Allows hot water to escape and cool water to enter. So it will release the pressure if the pressure is too high, but it will also release the pressure when the temperature gets too high. Combination temperature pressure relief valve. Testing is much the same. Before testing, if there's discharge piping, make sure it's free and clear. If it's a hot water system, your pressure must be 75% before a tri-lever test. This is just to make sure that you blow it out and it closes successfully. Safety valve leaks after tri-lever test, try several more times. And this is recommended about once a month, do a tri-lever test. Stop valve, shut-off valves. So to prevent draining of a boiler without emptying the system, stop valves placed in supply and return piping connections on hot water heating boilers. Purpose of the expansion tank provides a space to accommodate the expansion of heated water. So we heat up water in a hot water heating system. The volume of water increases as the temperature increases. We need a place for that volume of water to go. And that's why we have expansion tanks. Two types, actually three. So we'll look at the three types. Open type was an open tank, open to atmosphere. Sometimes gauge glass, sometimes not. The water level would be low when the system was cold, and it would move up in the tank when the system was heated up. But needed to be very, very high in the system, above any other parts of the system. Closed type expansion tank, so it's a tank that allows for room of expansion, partially filled with water, partially filled with air, has gauge glass, equipped with a gauge glass, partial water and partial air. Okay. Closed type expansion type of tank is 100% full when starting up. What's going to happen? We're just going to see that safety spilling water constantly. First thing to check, if you have a diaphragm type, check the diaphragm. And the next thing is check the level in your expansion tank. Oh, what is this? So I think you're all getting it now what this is. Call it a crystal ball or a memory bubble. That's what this is. Okay. Closed type expansion tanks. Air is easily absorbed by water. Air bubbles interfere with the water circulation. Tank should be large enough to accommodate the expansion of the whole system and have an airspace to provide that cushion. Expansion tank gauge glass should be approximately half full of water. Closed type. So notice the connection on the closed type tank with an air separator. So we have water leaving the boiler, going through an air separator, check valve, feeding our system. We'll have a look at an air separator, and we will note that it literally knocks bubbles of air out of the system. Those bubbles will be directed into that type of expansion tank. A repeat tank should be large enough to accommodate the expansion, still have an airspace, provide a cushion. Tank glass should be about 1/2 full. Gauge glass, just like a gauge glass on anything else, may or may not have or need the safety device. Some other fittings for hot water boilers that you wouldn't find on a steam system. Automatic film valve. Yeah, you would find these on a steam system, actually. Sometimes. Automatic fill valve, simply a pressure reducing valve, so important information. Pressure reducing valve keeps the system filled with water, maintaining a set pressure. If the pressure drops in the system, so if pressure is dropping in a hot water system, it generally means the amount of water in the system is dropping due to some kind of a leak. The automatic fill valve will open and feed water from a supply source. So another reason your PSV or your safety would be leaking or weeping as if this thing is set a little bit too high, a little bit higher than your system needs to operate at. Backflow, chapter 6, number 14, page 14. So, backflow prevention device. When you're connected to potable water, and need one of these devices, it means that you have a possible cross connection. And there's a little bit of conversation about backflow prevention on page 614. Backflow prevention is required to protect building occupants from contaminated boiler water. This is covered in much detail in later chapters, but to kind of set the tone for what is backflow, we need protective devices to prevent the possibility. So this device is connected to a boiler, hot water heating boiler. We have city water over here. City water is what? What kind of water? What's special about city water? What can I do with it?
Potable.
I can drink it. So if we had a problem in this device and maybe the city water main broke out in the front street like it did at my house 2 days ago, and I had a hot water heating boiler in my basement. Some homes have them, many homes have them. Buildings around the neighborhood, I was looking after boilers in a medium-sized building a few blocks away from here for a number of years. The water main breaks and the pressure in the boiler is higher than the pressure in the water main. This boiler water could go back into the water main. It would be temporary, but there would be a bunch of boiler water being fed. My whole boiler would likely be dumped out into the city water header. And once the crews had patched up and repaired the pipe and you had a drink of water the next morning, would you want to be drinking my boiler water? Not very likely. So bring in the backflow preventer. The boiler that I ran had a couple of check valves and one of these guys. And I don't know that we ever had a problem. I don't remember ever losing the water, but one day the guys from the city came knocking and said, "Have you got backflow preventers?" And I said, "Well, there's 2 check valves there. That would probably prevent backflow in most situations." He said, "Well, when were they last inspected?" And I said, "I have no idea." So they made sure that we had a very expensive and very complicated system to prevent that boiler water from going back into our system. And we'll look at that in much more detail in other chapters. So another thing in a hot water system, heating of hot water and moving it around and having it in an expansion tank with an interface with air. This water is going to absorb quite a bit of air, so we're going to have some potential for air bubbles flying around in our system. What happens if we get a bunch of air in there? Negative effects, things called airlock. Bubbles can build up, they'll find places to gather and collect, and then eventually you're going to stop your circulation. Your system is just going to run poorly. It's not going to circulate effectively, and efficiency is going to be crappy. So we have some air vents, automatic air vents, and some air separators. They look like this. This is a fitting called a scoop or an air separator installed in the boiler supply piping. So supply means it's the outlet of the hot water boiler. It says it traps the bubbles. It doesn't actually trap the bubbles, but water comes in and bubbles hit a baffle, and the bubbles will be directed to collect, but we need some way to get them out, and we will get them out. I got the right drawings here and they've escaped me. So we will get them out in one of 2 ways. We will have a connection to the expansion tank from the scoop or air separator, or we will have a connection just simply to one of these vents. And the old type were float type. Some modern vents are called hygroscopic. So this lets the air bubbles get released either to the expansion tank or to the atmosphere. Okay, if you have a closed expansion tank, this is the connection. The air will be vented into the tank. Some of the air from the scoop. And if you have the diaphragm or bladder type expansion tank, it will go to atmosphere through an air vent. So air vents are installed at all hot water piping system high points. So in addition to an air vent from an air separator, there will be air vents in different places designed to remove air that collects in the system pipe. Because trapped air can interfere with circulation, and that is a condition called airlock. And what that means, there's no circulation, so we're not going to move our hot water out to the places where we require it. And here's showing some air vents in different places. Okay. Air vents installed at the high points. So if your system goes up many stories and around and down, there's going to be some air vents in different places. In addition to that air separator closer to the boiler. All right. So I played a couple of videos. Did anybody get kicked out when that happened?
Yes, Mr. Ken.
Gray shear. Okay.
Yeah, around 7:52.
You were the only one.
I was kicked out around 7:52. The same
I'll play
time.
I'll play all the videos at a different time.
I got kicked out at 7:40, but I don't think it was during the video. I'm gonna try going downstairs closer to my system next class.
Yeah, either get closer or get a hardwired connection, and I'm sure that would help. So here's a air separator with an automatic air vent. So our boiler is supplying hot water this way through a circulator. That's a pump. Here's the air scoop. Simply has a vent, venting the air to atmosphere. Circulating pumps. Heating water systems need to have circulation. And typically we'll see circulators. They're pumps, they're centrifugal pumps, often with magnetic drives. We'll talk about that eventually. So we can circulate water through loops and circuits and zones. Hot water systems are kind of nifty because we can have multiple zones. So each zone would have a pump. We can start up a pump to a zone and they can have all the heat they want. One zone that doesn't want so much heat can be their pump can be shut down. And starting and stopping as we need different amounts of heating in the system. And can be just called a pump or generally referred to as circulators. There's another brand with its typical color. Some controls. Heating system boiler limit controls are operating and safety controls. That's just one paragraph on the last page in the chapter. So let's do a quick review of this chapter and we'll be going home. H glass safety valve. Quick closing is quarter turn and safety type has a small steel ball to close it should the glass become broken. Check valves allow flow in one direction, prevents flow in the opposite direction. Stop valve is something used for an isolation valve. Check valves can be swing type or lift check type. So there's the swing type, just a flapper. Flow holds it open and pressure, reverse pressure holds it shut. No spring or dashpot. So a lift check valve has this dashpot. That looks like some sort of weird gang tattoo, doesn't it? Blow-off valve is something on the lowest part of a boiler in order to drain the boiler, blow out the mud and sediment for lowering concentration of dissolved impurities. Dissolved impurities will be talked about in great depth in chapter 17 of book 3. High concentrations of solids can cause foaming, so that's why we need to get rid of those solids. Okay, might lead you to some videos to look at. They might be associated with later chapters, but they're very short videos. The blow off valves will be either two valves or one like this and one like this. Expansion tank and a hot water heating system. What does it do?
There's a place for the pressure to go for a little overpressure, but
Yes.
also equalizes your system, does it not?
Storage space for the expanding water. Yeah. Water expands, pressure would increase, but we need to give it a space. We add the expansion tank. Closed type expansion tank, the air is directed into that tank. So air bubbles are knocked out of with an air separator, go to this expansion tank. If we have a diaphragm type, the air is vented to the atmosphere. Hot water boiler pressure gauge scales, how many times pressure relief valve set? I showed you this before, it had a range on it, but only one of these is, actually this is a typo. So the answer the last time was between 1.2 and 3.5, I believe. So these are good. These are both good answers. I'm just going to make a note so I can fix that slide. 424. Okay, relief valves installed on the boiler or close to the outlet. What can be installed between the relief device and the boiler?
Nothing.
Nothing. No valves. Okay. Nothing. Nothing. Automatic fill valve. What is an automatic fill valve? What does it do for us? What's the best?
Back pressure?
It's a pressure
It's a
reducer.
pressure control valve.
Yeah, it's generally going to reduce the pressure. Our supply is going to be higher than the boiler, so we don't want it to pressurize the boiler, so we reduce the pressure. Okay. Back pressure, we're going to use backflow prevention. All right. And this has nothing to do with the air vent or controlling the pressure. Discharge from relief valve should be piped. So this is common now, they'll be connected. What happens at the other end of this pipe? Do we connect it to something or not?
The sewer.
Okay.
It should be
So-
close to the sewer, but should have some airspace between the sewer and the drain, from what I read.
That's an excellent answer. Not connected, but near a drain. Okay. If you connect it to a drain, you're going to pressurize the drain system, and that's not going to be good. And we'll look at drain systems in another chapter. But don't vent your safety release into a drain system. Okay, bad idea. How many safety relief valves? So what are we going to see on a hot water boiler, a thermometer? Safety relief valve, blow off or drain valve, and a water column. Maybe? No water column.
Nope.
Yeah. But how many relief valves?
At least one.
Yeah, at least one. We'll have a thermometer, we'll have at least one relief valve, and we should have blow off or drain valves. No water column on the boiler. It'll be on the expansion tank. So thermometer, safety valves, some kind of drain. Okay, pressure or altitude gauge hot water boiler does not require a siphon. Hot water heating boilers shall have thermometer. Hot water pressure relief valve installed on the boiler or close to the outlet. Ruptured diaphragm or full expansion tank will cause the safety relief valve to blow. We call it blowing. High lever test ensures the valve is free to operate and just simply takes a few seconds. Okay, it has nothing to do with adjustment or testing. So this is tri-lever. This is not a pop test. If the safety continues to leak, what are we going to do?
Work it a few times.
Give it a couple blasts. Hot water boiler stop valves so that the boiler can be drained without draining the system. Purpose of the expansion tank.
Allows expansion for water.
Number 4.
Yes. Closed hot water expansion tank connected to the boiler or the return line. Where does released air go to? It depends, okay? If you have a sort of a normal closed expansion tank, you're going to direct that air into that tank. And if you have a diaphragm, see, this is what the book doesn't tell you. It tells you that air is directed to the tank, but this is also a closed type tank. When you have this kind of a tank, you have to vent it to atmosphere. Closed type tank should be what? Full of water, open to the atmosphere.
Partially filled with water, partially filled with air.
Yeah, part and part, about half full. Purpose of the autofill valve. So we talked about the autofill valve. Why do we have one?
So the water system is continuously refreshed.
Replace water lost.
Only opens when you need a bit of water. Okay, we're not doing this. All right. Air vent, automatic air vent location. Where do we have automatic air vents?
All highest points of the system.
For the system.
High points, yeah. Low water fuel cutoff must be installed with no isolation valve. So 614, I know we didn't talk about that. Yeah, 614 low water fuel cutoff. No shut valves are allowed on this device that could isolate it from the boiler. Must be installed with no isolation. That's it for today. Those are pretty big chapters. Lots of stuff in those 2 chapters. I was glad it worked out. They were on a Thursday, those 2, or only 2 for a Thursday. Next week, book 1, chapter 7.